Let's construct a time series forecast using the least squares method. Now this will be the same as our part 8 linear regression, but we just use our years as our variables. So let's have a look at what we've got here. We need to follow the same format. So Cameron Taxis is trying to determine how many taxis to have in its fleet by 2022. The manager wants to construct a sales forecast for 2022 to give him extra information. Construct a sales forecast using the least squares method. So once again, we need to use our y prime equals a, which is our y-intercept, plus b, which is the slope of the line, divided by x, which is the variable. Now x is now changing from, say, hours studied, etc., what we used before, to the year. So we can set these variables as year 1, year 2, year 3, year 4, 5. 2021 would be 6. 2022 would be 7, and so forth. It can go on as long as you'd like. So to do that, we now also need to do the formulas for A and B. Now we have to solve B first because B is actually used in the equation for A. And we're going to set up our chart here to help us solve these quicker. So first things we'll do is we're going to include our variable. So this is just, I'm going to put this here. I'm going to add our variable numbers. And I'm going to have our x, which is our time, and give a sum of x, which would be 15. Our sum of our sales is 130.4. And we can take our x, y, which we'll need down here, and multiply across. So 1 times 8.7 is 8.7. 2 times 17.4 is 34.8. 3 times 26.1 is 78.3. And so on through the next couple. We'll also need our x squared. So we can square our x's. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. And this including these sum totals at the bottom. So we now have enough information to solve for B, so let's go ahead and do that. We have originally 5 observations. The sum of xy is 478.3. sum of x, 15, and the sum of y, 130.4. We have, again, 5 observations. The sum of x squared is 55. And the sum of x squared is 15 squared. So just be very careful where the exponent is. There's a big difference between these two. So we get a slope of 8.71 for B. We can use that now to solve A. Sum of y, 130.4 over 5 minus 8.71 times the sum of x, 15 over 5. And A is negative 0.05. So now, if we want to make a prediction of our year 2022, we can use the variable 7. Now the least squares method basically is, just like was described in the last part, going to minimize the difference between what the estimate will show and what we've actually seen over the observations. So y prime equals a plus bx, y prime equals negative 0.05 plus 8.71 times 7. And we get an estimate of 60.92. So Cameron Taxis can expect, based on our time series forecast using the least squares method, $60.92 million in sales in 2022 based on the growth that he's shown.